Uh, okay, if we start it, that is question number here 5. So we are asked to basically prove that 1 square plus 2 square uh, plus then it's up to plus n square, that is equals to n times n plus 1 times 2n plus 1. Okay. Okay, and over 6 here. Okay, we have to prove this one by using mathematical induction. So at first, if we just put n equals to 1, then here we are getting in the right side. So right side equals to uh, what is the what will be the right side? That is 1 times 1 plus 1. Okay, times 2 times 1 plus 1 over 6. So yeah, okay, then okay, I'm sharing it again. Okay, so here if we put just if we substitute n by 1 and this here right side, that means we are getting that is 2 times 3, that is 6. 6 over 6, that is 1. Okay, so here the nth terms, that is n square. So we can say here, but if it's just substitute n by 1, then we are getting n square, that is 1 square, that is 1. So now if we substitute n by k, then we are getting here, we can say here, here at first in mathematical induction process, we can assume that for n equals to 1, the given uh, the given term or given equation or even the given sorry, suffering from cough and cold. So for even n equals to 1, we can assume that the given term is right. Okay, that means right. Also for give n equals to k, then we are getting here 1 square plus 2 square uh, plus k square equals to, so we are getting here k times k plus 1 and then 2k plus 1. Okay, over 6. Now what need to be done here? Next part. Yeah, k square plus k plus 1 whole square. Okay, that means for n equals to k plus 1, so we are getting here 1 square plus 2 square plus dot dot plus k square. That means we have to just add okay, for k plus 1 square, we are getting here k plus and then k plus 1 square equals to uh, that is k will be substituted by k plus 1, right? Okay, then k plus 1, and then here k plus 2, and then here 2k, that means 2k plus 2, then 2k plus 3 over 6, right? Okay, now if we can prove that, now if we can show that uh, if we add here this term k plus 1 power 2 on both sides, k plus 1 power 2, if we add k plus 1 power 2 both sides, okay, then we are getting this left side, right? Okay, now the part is uh, we have to just calculate this part, and then after calculating this part, if we can show that this term equals to this, then we can show, we can say that the given theorem is proved. So that means, is it clear? So we just added k plus 1 power 2 on both sides of this equation. Okay. Okay. So it should be equal to this. That means we are getting left side. We see that the left side is same. So okay, there is no problem with left side. But here, if we calculate this one, and then if we find that this term is equal to this, then we can say the given theorem, we can say theorem, or that is proved. So our main part is to now calculate here. Okay, we have to calculate this. That means, so now k times k plus 1, and then 2k plus 1 over 6, then plus k plus 1 power 2. Okay, now we have to just calculate it, or we have to just simplify it. Then we will get here that is equals to, here this will be the same k, uh, if I just simplify this one, okay, then it will be k square plus k, uh, then 2k plus 1 over 6, and here we can say, if we simplify this k plus 1 over 2, then that will be k squared plus 2k plus 1, right? Okay, then LCM is 6. So now, uh, okay, if we just again multiply this term, then we are getting 2k cube, okay, 2k cube, then plus k square, then plus 2k square, then plus k, and then plus here 6 times k square, and then so 12k plus 6, right? Okay, now simplify this, here 6, and then 2k cube, so here in total 6 2 8 1 9, so 9k square, okay, right? So then 13 plus 13k and then plus 6. Okay, now we have to simplify this one. Or even uh, we have to factorize this one. Okay, and I think if you have if you face any problem to factorize this, then it will be easier for you to just expand this. Okay, so if we expanding this term, if we get the term which just we got, okay, so if we can just equalize this term with this term, then we can say the theorem is proved. So you can follow two processes here. First one is to factorize this term, okay, and then just yeah, thank you. Or even you can expand this one, then equalize it with this one. So which one looks easier? Simplifying or expanding, right? Expanding this term, I think it will be easier than the factorization. So basically, hence we are asked to prove, right? That means it must be equal. There is no way to not to be equal. So you can start also factor. No, no. We still we are not finished. Uh, I am saying that since we are asked to prove this, so there is no way not to be equal. And now we have to just equalize it. Okay. So we can, if we just focus on getting the term that is uh, here. Okay, here we are. We have to just find out factors k plus one. Oh, sorry, here one is missing. Okay, k plus 1 and then k plus 2, then 2k plus 3. So one factor will be k plus 1, right? So if we go for factorization, then what will happen here? If we go for factorization, then we will get just k plus 1. So we have to multiply with 2k square, right? Okay. Can you factorize this type of term that is a quadratic term? Sorry, not quadratic, cubic term. Cubic, right? So you have to just calculate two lines at a time, right? Okay. So here, if we go for k plus 1, then to get 2k cube, that means we have to multiply with 2k square. Then if we multiply this, then we are getting 2k cube and then plus 2 2k square, right? Okay. Now, if we just look at this term, we already had 9k square, but we just got 2k square. That means we have to write again 7k square. Okay. Okay. Then to get 7k square, we have to multiply k plus 1 by what? What term? It will be 7k, right? Yeah, 7k. So now if we multiply this k plus 1 by 7k, then we are getting 7k squared then plus 7k. Okay. Okay. Now, now, okay. Now again, if we go to this term, then we are finished this one. We have finished this one. Now we have to calculate here 13k. We are given. We have 13 plus 13k. Now we just got plus 7k. That means we have to add, or we have to put plus 6k here. Okay, to equalize. Okay. So now our okay, then here k plus 1. So we have here plus 6. That means we have to multiply with plus 6, right? Okay, so if we multiply with plus 6, then we are getting 6k and then plus 6. Okay, now go back to the first one. So it is 6. That means this line and this line and this line, three lines are equal. Okay. Do you follow this method to factorize a cubic term or any other method? Yeah. Okay. Now we can take common here k plus 1. Okay. So we are getting k plus 1. Then we have just 2k squared, then plus 7k, and then plus 6 over 6. So here, now we have a quadratic term. So quadratic, you have to factorize this one again. That means we will remain here, k plus 1 will remain here. And then we have here 6 times 2, that is 12. So now we have to make it 7, 12. Okay. So how can we make it 7? It can be 3 times 4. Okay. So 2k square, right? Okay. So it will be 2k square and then 3k and then plus 4k and then plus 6. Okay. Over 6. Then again here k plus 1 and then we can take common k. So we will get 2k plus 3 and then plus 2, then we will get k plus 3. Okay, yeah. So again here k plus 1. Okay, and here k plus 2 and 2k plus 3, not minus, plus. Okay, so the term we just got, that is equal to this, right? So hence the theorem is proved. Okay, same process. Yeah, same logic, right? Same logic for all. If there is not mentioned that use the principle. No, but you can use this. Okay, if we go for another example, then it will be clear to you. Here, number 6. Okay, so how can you prove it? Okay, okay, and then n equals to k plus 1 for n equals to k plus 1. Yeah. So since here we are given in index form or exponential, not exponential, index form. So you have to know the rules of exponents or indices. That is for calculating. Okay, you have to know the rules of indices. All are same. If you just go for this one here for n equals to 1, for n equals to k, and then for n equals to k plus 1. Okay, same process. Just calculations are different. And here, if you go for question number 7, here also for n equals to 1, then n equals to k, and then for n equals to k plus 1. And then you have to do some calculations. Now, is there any other? Basically, this type of problem is for paper 1. Since here you don't need to use calculator. Okay. Yeah, yeah, for paper 1. Now, can you try number 3 from 15? 9 marks for this question. That means it will require use calculation. Root R. Okay. So how can we start with? Okay. Uh, the difficulty level of this question is hard. Here you have to start with n equals to 2. Now here given r equals to 2 up to n. So you are, yeah, you are starting from 2, right? Okay, so you have to put n equals to 2 here at first. N equals to 2, because here the value of r equals to 2. Okay, so the value of r is starting from 2. That's why we have to just start with 2. Okay. And then n equals to k plus 1. Is there any doubt? Okay, okay. Here basically, okay, okay. Sorry, can you repeat it again? What you said? Okay, I got it. Here basically, so for k uh, r equals to, so for r equals to k plus 1, we are getting okay, at first k, okay, we are getting basically that is summation r equals to 2 over k. So we are getting here 1 over r, and that is less than 2. Okay, okay. Oh, okay, okay, okay. Can you see it now? Okay, okay. Now, for r equals to k, for r equals to k, we are getting r equals to 2 that is starting from 2 and it will be up to k, and here 1 over root over r, that is less than 2 root over k minus 2. Okay, for r equals to k, right? Now if we put r equals to k plus 1, then we are getting here uh, it will be okay, summation r equals to 2 to k plus 1, and here 1 over root over r, and that is less than 2 root over k plus 1, then negative 2 minus 2. Okay, so basically for r equals to k plus 1 we are getting this. Now, what was the method, or what was the process to prove it? To prove it, now we have to just add k plus 1 term, right? K plus 1th term over here with this and also with this, right? That means, okay, that means if we add here uh, in left side, that is r equals to 2, starting from r equals to 2, then that will be k, and then here 1 over root over r, then plus, if we add k plus 1 term, then it will be 1 over root over k plus 1, right? Okay, and in right side here also we have to add this. That means here 2 root over k minus 2, then plus 1 over root over k plus 1. Okay, okay, so what does this term means? This we can be rewrite as summation r equals to 2, and here it will be k plus 1, right? 1 over root over r. Is it clear? Since it's up to k term, right? So we have added another term, so it will be k plus 1. So now we just got here this one, left one, that is this, right? Okay, now we have to calculate this. We have to calculate this, and if we can show that this one is equals to this, then we can say that hence the term is proved. So now we have to do some calculations on this. Here they have skipped some calculations. That's why it looks very odd. Okay, now if we try to calculate this one, then we will have we are getting here uh, k root over k plus 1 as denominator, then it will be 2k root over k, and then minus 2 times here root over k plus 1. Okay, and then plus 1. Is it clear? Okay, 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 okay. So now simplify this. Okay, here, no, 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 not k plus 1 will be cancelled. Here, Basically they used here, okay, I see here, basically they used the calculations of this this term from 1. Okay, no, you didn't got it here by part A. Okay, okay, I just show you the calculations, so it will be easy for you to understand. Here now, uh, if we go for calculations, then we have here that is 2 root over k plus 1. Okay, here uh, it will be just okay. mm, okay, here they used 1a, 1a, that means question number 1. Since here 1 over 2 root over n plus 1 less than root over n plus 1 negative or minus root over n. Did we miss some part? Okay. So if we look at the number A1, question number 1, we are given here, show that uh, 1 over 2 root over n plus 1, right? N plus 1, that is less than root over n plus 1, then minus root over n. So now, if we just substitute n by k, then we are getting here 1 over 2 root over k plus 1 less than root over k plus 1 minus root over k. So now if we multiply with 2, then we will have here 2 times 2 times here, 2 times 2 times. So 2 and 2 will be cancelled here. Then we can write 1 over root over k plus 1 less than root over 2 root over k plus 1 minus 2 root over k. Okay, is it okay? This calculation. Okay, now here we don't need to calculate this, or we need to here just use LCM or simplify this. Okay, now here just it will be 2k root over k and then minus 2, and then we can rewrite this. We can replace this here, this term by this. Okay, so it will be plus 2 root over k plus 1, then minus 2 root over k. Got it? Have you got it? Okay. They used it, yeah, they used it from 1. So here this term is less than this. That's why they used substituted this term with this. Okay, now we can just cancel out these two terms. Then it gives us 2 root over k plus 1 minus 2. So that is the basically our right side of for any r equals to k plus 1. Here is the this one is the right side. Here is the right side. Order equation. Yeah, right. So copy this one. Okay. Uh, so if you need to reasoning here in some questions, then you will get that. But if you miss the reasoning part, then you will not get the marks for reasoning. Okay, and then accuracy marks also are there. Follow through marks are there. Okay, and then just if, no, basically methodology, accuracy, and follow through reasoning. These are mostly used. Okay. Then you go through just go through this sheet or this link, and then try to solve some problems on mathematical inductions. If you face any problem, then just note it out and then let me know. And also in binomial expansion. Okay. Next. Okay. 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 Thank you.